All right, this example says, suppose the ordered pair t comma d gives the displacement in centimeters of an object undergoing simple harmonic motion at time t in seconds. And it tells us that the object has a minimum at 24 comma 32. So that would be here. And then it has the next consecutive maximum at 48 comma 54. That would be there. And using this information, we want to write a model representing the displacement as a function of time. All right, so let's take all the information that we're given and see if we can discover some more information that might be useful to us as we try to create this model. So one of the first things that I noticed is that it took 24 seconds to go from a minimum to a maximum. That means it should take another 24 seconds to go from a maximum to a minimum. So we should have another point on this graph at 72 comma 32. We can use that same thought process to say, okay, well, if we had a minimum at 24 seconds and we go backwards 24 seconds, we should have a maximum again. So it looks like we're reaching minimums and maximums every 24 seconds. And so I'm thinking a rough graph of this function is going to look something like what we have here. One of the first things we're going to need to write our model is the amplitude. And the amplitude is just half the distance between a bottom and a top. To find half the distance between a bottom and a top, let's take a top, subtract from that a bottom, and then we'll divide that in two. 54 minus 32 is 22, and 22 divided by 2 is 11. So we know the amplitude is 11. We also need to find our equilibrium. We can find the equilibrium a couple different ways. We can either take a minimum value, which in this case would be 32, and add the amplitude to find the equilibrium, or we can take one of the maximums, which in this case would be 54, and subtract the amplitude to find the equilibrium. 54 minus 11 is 43, or 32 plus 11 is 30, or 43 rather. So our equilibrium is going to be at y equals 43. So our equilibrium will be right here at 43. And when we find the equilibrium, we've also found our vertical shift. Our vertical shift. Because we can tell that the graph of this function has been shifted up 43 units. Now let's find the period. This looks like a cosine curve. So as we complete one cycle of the cosine curve, we notice that it takes us 48 seconds to complete one cycle. So the period is 48 seconds. And then we can use the period to help us find our omega, or b, because we're going to need that to write the equation for this function. We know that the period, 48, is equal to 2 pi over omega. Cross multiply, and we get 48 omega equals 2 pi. And then solve that for omega by dividing both sides by 48. And we get omega is equal to pi over 24. The last thing that we need to determine, and it's pretty obvious from looking at all of our information here, but we still need to make this decision, is are we going to model this using a sine curve or a cosine curve? Well, obviously, because we're at maximum displacement when t is equal to 0, this is going to be a cosine model. And to back that up, this looks like a cosine curve, right? So anytime we are at maximum displacement, when t is equal to 0, we will use a cosine curve to model, or we will use the cosine function to model that specific situation. And it doesn't matter if the maximum displacement is a positive displacement or if it just happens to be a negative displacement. It doesn't matter. If we're at a positive or negative maximum displacement, when t is equal to 0, we'll always use cosine. Contrary to that, which is not the case here, obviously, if we were working with a situation where there was no displacement when t is equal to 0, if there's no displacement when t is equal to 0, then we know that we will use a sine curve to model that specific situation. So now that we have all of our information, we can put together our equation to model this displacement. We would have d is equal to our amplitude, which is 11, times, and we said we had to use a cosine function because we were at maximum displacement here when t is equal to 0. So we have 11 cosine of pi over 24 t. And then we had a vertical shift of plus 43. So there is our equation modeling this specific situation.